Hey everyone! In this video, we're going to look at programming the Flipper Zero using the Flipper Zero game engine. The game engine was first used in the Air Arkanoid game, which we'll be looking at today. This video will help explain key concepts if you want to edit or create your own game using the Flipper Zero game engine. Let me know in the comments if you'd like me to make a video where we edit the Air Arkanoid game, adding new levels, or if you prefer, we try to make a new game. Let's get started. Here you can see the 4 levels that make up the Air Arkanoid game. And here you can see each of the entity objects that make up each level. The Air and Arkanoid are custom images, which are called sprites. In our level game, we have a collider associated with each entity, so we can tell when 2 entities collide. Our collider can either be rectangular or circular. We use vectors to represent the x and y coordinate of each entity. Next, let's look at the steps to clone Air Arkanoid on official firmware. First, we'll go to the repository. This is where Air Arkanoid is, and you can see there's our Flipper Zero game engine. We'll go to Flipper Zero Good Faps, which is the root project. And then under code, we'll hit copy. Then we'll switch over to Visual Studio Code. And we'll go to our command palette. And we'll do a get clone and make sure it says recursive. So there's 2 get clones. You want the recursive one. The recursive one will pull in that game engine as well. Go ahead and paste in the URL and say clone from URL. And then here we'll go ahead and just add output folder. So I'll put it into a Flipper. And then we'll choose Open in New Window. Next, we'll right-click on Air Arkanoid and say Reveal in File Explorer. There's that project. We'll go ahead and hit Copy, Control-C. And then over in our main project, we'll right-click on Applications User, say File Explorer, open Applications User, and then hit Paste. At this point, you should have an Air Arkanoid inside of your Applications User. So you can go ahead and click on Terminal, Run Task, and then choose Launch App on Flipper. And make sure QFlipper's not running. And with any luck, you should now have the application running on your Flipper Zero. Next, let's take a look at why those sprites didn't load. It looks like the PNG files are set correctly. That's in the sprites folder. And then in our application FAM, we have the ext build. And that ext build will take those sprites and it will output it into our assets sprites as fxbm files. So that looks correct. And then in our levels, you'll recall we were in the level menu. And in our level menu, we are loading that fxbm file. We pass in the name of those files. And that entity is a moving sprite description, which uses moving sprite update and moving sprite render for rendering. That moving sprite render is doing a canvas draw sprite at our entity get positions X and Y, so that looks correct. Our moving sprite init looks like it just sets the start and end positions. So that looks correct. This start value is 256 and it actually should be 0. The firmware has since changed so that instead of being offset, you actually want to start it at 0. So let's go ahead and change that to 0. And then we'll make sure QFlipper's not running and the application isn't running on our Flipper Zero. We'll do launch. And now we have that Air Arkanoid, and we go in and out. There's that animation. Next, let's take a look at the game engine. And in the game engine, you'll find the main.c file. And in our main.c, this is the entry point of our game, game_app. And this will kick off a game manager and run the game that you've defined. In engine.h, it's going to pull in what a level is, what an entity is, the game manager, the game engine, and then one of those files will also pull in definition for vector. So basically, once you've included engine.h in your code, then you're going to want to define this. There's this extern const game. And so we define what's in this game variable. And a game basically has a target frames per second, whether or not to show the frames per second, if the backlight should be on or off, and a method that's going to get called when the game starts, and a method that's going to get called stop when the game is ending. Your application context or your game context is a structure that stores any settings or state that you need, such as the list of levels or the current score or the IMU reference, etc. You pass in a size t, which is the size of that context. The game engine will automatically allocate that context and pass it into your start and stop methods. So now let's go back, and in our application, we'll go to app fam. And you can see there is our entry point where we're passing in game_app. So that will run that engine main.c. And then in our game.c, there's that variable we talked about. We're defining what the game variable is. We're passing in 30 frames a second, which is fairly typical. We're not showing the frames per second, but there is a settings that will enable you to show those frames later. We're always turning on the backlight, so it's easy to see, especially with the VGM, where the user is not clicking on the D-pad. The screen often will turn off, so passing in true is very helpful if you use the video game module. And then we're saying game start is what's going to get called, and game stop for our stop. You can see in our stop, we're freeing that IMU, which is our video game module sensor. And then we're closing our record notifications, which we use for the sound and vibrate. So in our game start, you can see we allocate that IMU. And again, that's the video game module. As soon as you call alloc, it's going to calibrate as well. So ideally, when someone starts our game, we want the video game module not to be moving, and we want it in a typical orientation. IMU present just tells you whether or not the IMU was detected. And then you can see we're adding those 4 levels we talked about. So we're adding a level using level menu, level settings, level game, and level message. If we go into our level game.h, you can see we've defined that level behavior is level_game. And then in our level_game.c at the bottom, we've defined a level behavior called level_game. Our game doesn't do anything when we alloc, and it doesn't do anything when we free. When we call start, it's going to actually spawn all of our entities. And when we call stop, it will clear the level of any entity. And our level doesn't have any state, so our context size is 0. So for that level game stop, you can see we're just calling level clear and passing in a reference to our level. And that will remove any entities that are associated with the level. So this behavior is kind of typical when you have a level where items are getting removed as gameplay happens. In our settings and in our menu, those are static. And so we usually do things in alloc. And then in our start, what we're doing is setting the default positions of anything that's animating on those levels. So let's go ahead and look at level game start. Level game start is just calling level 1 spawn. And level 1 spawn is calling level add entity. This is how we add entities to our level. We pass in the level and we're passing in a reference to a paddle desk. If we scroll up a little bit, you can see that paddle desk variable. And paddle desk has a start that's going to get called when the entity is added to the level. Stop, which is going to get called when the entity is removed. An update, which is going to change the position of the entity. A render, which is going to draw the entity on the canvas. Collision, which is going to happen if the collider for our entity and the collider for another entity overlap. An event, which is going to happen if a custom event is sent to our entity. And finally, our context size is the size of paddle. So we'll go ahead and look more at that paddle. Let's go to paddle start. And up above that, actually, you can also see that paddle context, which is we have a vector, which is the size of our paddle, a Boolean, whether or not the ball has been launched yet, and also a reference to the ball. In our paddle start, we have 3 parameters. The first parameter is our entity. The second parameter is our game manager. And the last parameter is that paddle context. So we go ahead and convert that context to a paddle. And then we set the size to our paddle start size. And we set ball launch to false, so the ball will follow the location of our paddle. And then we set our entity's position to an X position of 64 and a Y of 61. You remember the flipper is 128 by 64. So this is centered and near the bottom. And when you call entity position set, that's typically the center point of your entity. Next, we add a collider rectangle, and that collider rectangle is going to tell us whenever the ball intersects with the paddle. Finally, we get the current level, and we call level add entity, passing in the level and a description of our ball. And our ball description has a start, an update as the ball moves around, a render to draw the ball. It does not have a callback for the collision. The callbacks will be on the block and on the paddle. And you can see when we start the ball, we're going to call ball reset, which is going to set its max speed to 2. Initialize the speed of the ball to not moving, 0, 0. And the size of the ball is 2. Finally, we add a collider, a circle, based on the location of that ball. You can see in ball update, we're manipulating the location of the ball. And when the ball goes to off the bottom of the screen, then we're calling level send event, saying game event ball lost, and we're passing that to our paddle. Finally, at the end of ball update, we update the position of our entity. In our ball render, we're simply drawing a disk. So paddle update is interesting. So for the paddle, we want to get user input. And so we use game manager input get, and that gives us this input state, which I think I can peek at. And we have a held, which is what buttons are being held, which buttons just got pressed, and which buttons just got released. The type of things are things like game key left, game key right, game key OK, game key back. And if the IMU is present, we're using this paddle X from angle. And it's basically converting the pitch into a coordinate so that you're able to move the paddle instantly to wherever the pitch is. Where when you're using the D-pad, it is moving the position, incrementing or decrementing by 2 for each frame. And then here we're clamping both the IMU feedback and the D-pad feedback. And then we're setting our entity position. Finally, if the user presses the back button, then we go back to that menu. Another area that's interesting is to look at paddle collision. And so this happens when the paddle collides with another object, which is most likely going to be the ball. And we call entity description get, and we see if the other entity we're colliding with is in fact matching that ball description. If it is, we do the code to make the ball bounce off the paddle. Let's go back up and look at the block collision. So the block collision, we're checking to see if it's getting collided with the ball. If it is, we're calculating how to change the ball. But more importantly, we're doing a level remove entity to destroy the current block. And then we're checking the level entity count to see if all blocks were destroyed. If all of them are destroyed, we print a you win message. This is where instead we could update this to go on to a new level. On my wiki, I've created a page for the FlipperZeroGameEngine. It talks about those concepts, game, level, entity, sprite, vector, and game manager. And it also talks about that sensor library for getting the pitch, roll, and yaw from the VideoGameEngine. It has references to the existing games. It tells you the command to type to add the game engine to your game. We talk about the methods needed to access the IMU to get that pitch, roll, and yaw. And then we talk about how to do the entry point in your application FAM, define that game structure and what the properties are. We talk about the level behavior and what those properties are. The entity description and how you do the render. The game manager with its add level, and also that's the thing we use to load sprites. That's preferred over just using sprite alloc because that way the game manager can keep track of it for you. We looked at game manager input get to get those different keys. Game manager game stop is how you end a game. And then for level, there was that level add entity to add our entities to our level, and level remove entity for destroying those bricks. Level clear we saw when the game ended, when the level ended, sorry. We saw a level send event for sending messages to a particular entity. Then it gets into all of the entity and colliders. If for whatever reason you want to offset your collider and not have the position be the center of your entity, there is methods to do that. And then we looked at that vector with its X and Y coordinates. There's also a bunch of functions. And in later versions of the game engine, these are using pound defines. So you can use vector add and pass in floats or integers for add, sub, multiply, and divide. And then we looked at what we needed to do in the application FAM to get sprites working and how to draw a sprite using Canvas Draw Sprite. And then finally, it talks about kind of when your game starts, what method's going to get called, while you're playing, what gets called, when you remove an entity, what gets called, and when you switch levels, what gets called, and when you exit, what gets called. I'll reformat this so it's a little bit cleaner. But hopefully, between this video and this wiki, that's enough to help you get going with using the FlipperZeroGameEngine. If you have any questions, feel free to reach out to me on Discord. Please like and subscribe. I appreciate it. And I look forward to hearing about what kind of game you're going to make with the FlipperZero.